Good afternoon. My name is Dr. Rishikesh Bharti, and I am the course instructor of this remote sensing and GIS course. So today is the second live session of good afternoon. My name is Dr. Rishikesh Bharti, and I am the course instructor of this remote sensing and GIS course. Good afternoon. My name is I hope I am audible. So one thing I wanted to just tell all of you, those who are attending my course, that in this semester there are few PMRF students who are involved as a TA in this course. So probably you might be getting few sessions from the PMRF students. So if you have any specific questions related to what he or she is delivering, you can contact them directly. But if you have any questions related to this course, my content, my videos, I will be happy to help you. So if you have any question, because as of now, I have not received any question. So if you have any question, then we can discuss today. So I'll just wait for your queries. Yeah, one question that is asked by PP Hazarika. Is there any negative marking exam? See, for the exams related thing, you refer to the NPTEL website, and specifically my web page, the course web page. There you will get all the information about the examination, how we do the grading, how exams are conducted, what are the different modes, what are the fees that you have to pay, what are the different categories of the certificates. So everything is given there. So you please refer to the course web page.
Hello, sir.
Yeah.
Good afternoon, sir.
Good afternoon.
Sir, I have a problem from week number 2.
May I know your name, please?
Sir, Somrat Mondol.
Okay. Yeah, please.
Sir, estimate the reflectance value of highlighted DN of Landsat 8 band 2 image. Sun elevation angle 58.0686. Yes, sir, there is given one matrix 3 by 3. That is 7,500, 14,390, and then 13,250. Next column 13,545.
See, I will not be able to like recreate the questions now. So you tell me your concern. What exactly is your concern? Because your problem may be very specific, right?
Yes, sir.
Yeah, you just.
So I have used that formula, sir. R2A. That formula is pi d square L lambda by sir E sun sun I lambda in 2 cos z. Sir, here the z is the z angle is 90 degree minus sun elevation angle, that is 58.06. 90 minus 58.06, that is z. And for E sin I, so this one is for exothermos
Exoatmospheric.
Exoatmospheric, sir. Exoatmospheric. So for the Landsat 8 band 2, so this value should not be considered for Landsat 8 band 2.
Right.
Okay, sir.
So I will tell you. I think I have got your problem. So basically, when we use this reflectance calculation, any equation, so basically, why at all we are interested to estimate the reflectance? Because reflectance is a unique value. And when we talk about DN value or radiance value, these values are actually influenced by the illumination condition. If your illumination condition is very strong, very good, you will get high DN number or high radiance value, right? But when we calculate the reflectance value, it is the ratio of radiance and irradiance. So here basically we are nullifying the effect of your illumination condition. And once we calculate the reflectance value, it is a unique value. And for any given material, the reflectance value corresponding to the wavelength, that will never change, right? So if it is not changing, it is a unique value, and it can be considered as, like, for human being, we are using the fingerprint, right, to identify the material. Similarly, if we critically review the reflectance value across the wavelength, we can identify the material property, right? So the chemical composition, internal atomic structure, those things we can quantify. Now, another thing is, when we calculate the reflectance, there are two types of reflectance. One is surface reflectance and another one is top of the atmosphere reflectance. When we talk about the surface reflectance, when we have all the parameters related to our atmosphere, when we can model our atmosphere accurately, and if we do that and then we calculate the reflectance of the any material, then we say it is a surface reflectance. But the surface reflectance, suppose next day I am downloading a data for like XYZ location, and I am using some standard formula, standard value from published literature, and I am calculating the reflectance. So that won't be my surface reflectance value. Understood? So what we do is we go with the top of the atmosphere reflectance. And why do we call this top of the atmosphere reflectance? Because we are not characterizing our atmosphere, and the irradiance value which is stored or captured by the sensor that is at the top of the atmosphere. However, the reflectance, the radiance value or DN value which is captured by the sensor, it has interacted with our atmosphere. So one value with the interaction of the atmosphere, another value irradiance value that is without interacting with the atmosphere. So when we use these two values, we call it top of the atmosphere reflectance. And when we say irradiance value, so here the exoatmospheric irradiance value is used because that is sensed or that is captured by the sensor itself, and that is exoatmospheric, that means above the atmosphere. So that is why this is exoatmosphere. And remember always, this reflectance value doesn't matter whether it is surface reflectance or your top of the atmosphere reflectance. These values will be in the range of 0 to 1 if it is absolute value. In percentage reflectance, it will be 0 to 100%.
Okay.
I hope I answered your question.
But sir, how to solve this problem? I've tried using this formula, but answer is not coming, sir.
Okay, do one thing. For you, what I can do is, you can just calculate it in a white paper, take a picture of that, and you can email to me, right?
Okay, sir.
Right. Then it will be easy to understand what exactly email you
Sir,
send it
email
to.
address, sir.
Email that here the discussion forum is there. In that you can post it, so others will also get the benefit of your doubts.
Okay, okay. In discussion from.
Yes, yes,
Okay.
yes, yes.
Okay. Thank you, sir.
Okay, thank you. Then another question is from explain. This is a first week assignment question. True or false? Optical images captured at night is an example of active remote sensing. So what is active and passive remote sensing? Active remote sensing, where we have our own source of light, right? And passive remote sensing, when we are relying on the sun. So sun is only available during the daytime. So whenever we capture images during the daytime, and directly, indirectly, if we are using the sun as a source of energy, we call it passive remote sensing. The active remote sensing, when we take our mobile camera or any DSLR camera, in the night when you click, you will also use your flashlight, right? So that is the best example to understand what is active and passive remote sensing. During daytime, you are using the sunlight as a source of energy and you don't need a flashlight. But in evening and night, you need a flashlight to capture the images. So whenever you are using your own source of light, it is called active remote sensing.
Hi, so I have one question. I mean, in continuation with the previous question. So
Yeah,
the question basically states that clicking photographs during basically remote sensing during the night is active remote sensing. So in that case, the answer should be true, right? Because I mean,
yeah.
in the answer key, it is false. Like the answer key says that it's false.
Optical images. See, in optical images, thermal remote sensing also comes, right? So this, when we say optical remote sensing, it covers 400 nanometer, from 400 nanometer to 16,000 nanometer. That means it is covering the reflective and thermal domain, right?
Yeah, got it.
So
Thank you.
you understood?
Yes, so hence it is first. I
There was
understood, yes.
yeah, there was a trick, right? So all the questions are conceptual questions. Shall we use calculator to solve the problem? In the exam, you will be provided with the calculator in the system itself. You will not be allowed to carry any calculator. You please read the instruction in the course web page. Everything is given, and in details, everything is given. So once you read that carefully, you will not have any questions related to evaluation, how we grade this course. So everything is given. Hello, Ravindra. So before we close this session, I want to thank all the participants, all the learners. Thank you for choosing this course, and I hope this course will give you the basic information as well as the advanced information. And maybe after attending this course, you can start working with the remote sensing and GIS. And but remember always, this is a tool that can help you to get some information which is required in your achieving the main aim of your research, but this is not the complete solution, right? So this is always remember, this is a tool. Thank you.